Okay, for today, we are doing a little bit more review for our test in Honors Pre-Calc. The test is on circle trig. And so part of circle trig involves simply finding lengths of arcs. So would you see if you can figure out the length of this arc if the angle is pi over 3? By the way, what is pi over 3? 60. All right, that's a 60-degree angle. And the radius is 8. And there's a formula for that. Raise your hand if you've got the formula down. You remember that formula. Only a couple of you? Seriously? What do you think it is? Yep. The SOAR formula, S equals theta R. All right, so what can we stick in where? Do we know the S, the SARC, as I've called it, the SARC length? No, that's what I'm trying to find. Do I know theta? Theta is the central angle. I know it, pi over 3. So S equals pi over 3 times R, the radius, which is 8. Would it be reasonable to say the answer is 8 pi over 3? Yeah, it feels weird because it seems like I'm giving an angle answer, but it's actually a length. How is 8 pi over 3 actually a length? Because it's just 8 times 3.14 divided by 3. Don't think that pi somehow stands for angles now. Pi just still means 3.14. Okay, so why is this better than actually typing in a calculator and getting a decimal answer? Well, for one thing, you won't have a calculator on your test. And so you won't be expected to multiply that out by 3.14. And besides, if you did, it wouldn't be it'd still be kind of accurate, but it wouldn't be what? What's the word for it when it's perfect? Exact. This is exact. Whereas as soon as I use 3.14, 3.14 is a rounding of pi, and it's not exact anymore. It's going to be an estimate. All right. So there's your answer. It's 8 pi over 3. That's how long this is. And if I had to estimate this, do you get that I kind of could sort of say that the 3's cancel and it's about 8? I'm totally, I know that's exact, not exact at all. It's rounding, but pi and 3 would kind of cancel each other. Again, it's not perfect, but it's a good estimation. It's about 8. Would you think it's a little more than 8 or a little less than 8? A little more than 8. Okay. All right. And now I know this means more. Hey, okay. All right. So anyway, how about if I give you a circle's area and I say, well, first of all, do you remember the formula for area of a circle? I hope so. What is it? R squared. So if this is 8 and you knew the area of this thing would be exactly what? Pi r squared, so 64 pi. Good. But what if I only had a quarter of the circle? I have 64 pi was the area, but now I have only part of it. What part of it do I have? Do I have half of the circle? No. And what we usually say is in terms of degrees. So let's say, how many degrees is this? 90 out of 360. Do you get where I'm going with this? To find the area of a sector of a circle, you can have this little fraction of the area of the circle. So here's the area of the circle, pi r squared. And if you have this little fraction of the circle, that could be in degrees, in which case it would be some degree out of 360. Or it could be in radians. Like, for instance, if I knew that this was 2 pi over 3 or something like that, that'll make it bigger. It was like this. Okay, 2 pi over 3 out of how much total in radians is there? It's not 360. If it's radians, it's 2 pi. All right. So I'd like to do one like that. Do you agree that that could be about 2 pi over 3? And let's say that the radius is about 10. I'd like you to tell me the area, not of the whole circle, then we wouldn't have needed this angle. The area just of this wedge of this circle. And pause for a moment while you give that one a try. Again, you find the area of the circle, and then you find a part of that area. And if you want to change this into degrees, you could, but I'm telling you, it's easier really if you just don't take it out of 360 degrees, take it out of 2 pi, and because it's already in radians. We do more stuff in radians in circle trig than we do in degrees. So you're trying to find the area of the blue wedge. I'm going to get you in groups right now. Okay. So the area is some part of pi r squared. And you could say it in degrees, but I told you that you might want to know how to do that in radians. So then it would be the angle out of 2 pi times pi r squared. Well, I know some of this stuff. In fact, I know all this stuff. I know theta, which is 2 pi over 3, over 2 pi. Hopefully you know how to handle fractions in fractions. That's why we do the top 20. One of them, anyway. I put that over 1, and then I can flip and multiply. Anyway, and then I have pi r squared, which is pi times r, which is 10. 10 squared is 100, so 100 pi. And then I hope you were able to go flip and multiply 2 pi over 3 times, flip it, 1 over 2 pi, and ooh, the 2 pi's are just going to cancel right off. And so that's 1/3 of pi times 100, or 100 pi. So that's 100 pi over, and again, I canceled my 2 pi's. There we go. So I have 1/3, so 100 pi over 3. Raise your hand if you had that one right. Okay, awesome. Maybe it doesn't feel like that's 1/3 of the circle to you, but if I divided it up, if this was actually the right number of degrees or the right number of radians, then I should be able to make a second one that's like maybe like here, and this would be another 2 pi over 3, and this could be another 2 pi over 3, and it's 1/3 of the circle. Okay. Yes.
So what happens to all the pi on the angle cancels out?
Yeah, this 2 pi over 3 and this 2 pi over 1.
Where does 2 pi over 1? Oh, is it the missing half of it, of the radian?
I don't know what you mean by that, but this 2 pi and this 2 pi are the same thing. And the angle is right here. 2 pi over 3 is that angle right there. So it's 2 pi over 3 over 2 pi. And then I just do some flipping and multiplying to figure out that it comes out to 1/3. All right. Now let's go backwards. I know this wedge has a radius of 10. But I know that the area of this is 40. There's a lot of things I could ask you to figure out, but if this blue area is 40, what I want to know is what's that angle in radians. No calculator. The area of the blue section is 40. What's that angle got to be? I'll pause, we'll give that a try. All right, I've added on one little question. Find theta, the angle, the central angle, and then find s, which is the length of the arc. That's the little like distance on that circle there. I'll pause, we'll give a little time, give you a little time to figure that out. Okay, this answer is weird, disturbing. Doesn't make that much sense because you're used to angles being things like 20 degrees. And now you've sort of gotten used to the idea of like, okay, it's pi over 6. But what if it's like 1.03? That's an angle. As long as it's in radians, yeah. This one's a, I think I'm, oh, no, I'm just going to find out exactly what it is. But all right, so I start with the whole little formula. The area will be whatever I wanted in radians. Okay, so I wanted this answer in radians. So that's going to be the theta over 2 pi times pi r squared. Okay, but I know the area. I was told the area was 40, so I could put a 40 right there. And I know pi is still pi, and I know r squared is 100, so 100 pi. So you just have to solve for theta. Okay, so now I'm going to go 40 equals 2 over 2 pi, And then I'm going to divide both sides by 100 pi. And now I'm getting, oh, that's a theta, sorry, theta. There we go. And now I can just get a little bit further by multiplying both sides by 2 pi. And I'll have 2 pi times 40 over 100 pi. And a bunch of stuff's going to cancel in a second. And then let's see, the 40, I'm going to cancel off one of the zeros on that and one on that. And I'm going to cancel the pi's. Cool. And then 2 times 4 is 8 tenths. Ooh, cool. 8 tenths, which is 4/5, is theta. 4/5 of a what? 4/5 of a degree? No, 4/5 of a radian. What is 4/5 of a radian? Do you get it's a little less than 1 radian? Remember a radian's like 57 degrees? Okay, so it's like a little less than 1 radian. In fact, if you wanted to know exactly how many degrees it was, you could figure it out by going, well, that's radians, and I can either multiply by pi over 180 or 180 over pi. And if I want to have degrees in my answer, I would say it's 180 over pi. And then you could multiply that all out and find out exactly how many degrees it is. You don't have to, but you could. All right. So if it's 4/5 is the angle, and I know it feels weird, but it's 4/5 of a radian, then what's the arc length? Well, S equals theta r, and that makes it really easy. I know theta, it's 4/5 times r, and the radius is 10. And so then this would be, let's do a little canceling. 10 is the same as 5 times 2, and the 5s will cancel. And this would just be S equals 8. Cool. Yes? There is no unit for radians. You are correct. So when I say it's 4/5, I just say 4/5. You can write, I'm not going to mark you wrong if you write out the word radians, but there is no little symbol for it because technically it doesn't have a unit. That's the reason this actually works, because if your radius is in inches and this had a unit, your answer would be in like inch degrees. You know what I mean? All right. Okay. That's as much as I'm going to say on that. Yep. Now let's talk about some of the other stuff that we've had. You know, the kind where you get 2 answers from 2 different places on the unit circle? Probably the hardest thing, I think, for kids. If I say, I'm not telling you the angle. The sine of the angle is this. And then you got to go figure out what the angle was. All right. Sine of theta is -1. Figure out what theta is. Sine of theta is -1. Hint, it's not one where you can draw a triangle. Because if you go, wait a minute, so he said sine, so then I'm going to put this over 1, and then I'm going to say opposite over hypotenuse. You'd figure out eventually that, wait a minute, the opposite say the hypotenuse side can't be the same. So how on earth could sine be -1? There's a way. It must be one of those special kind. What kind are those again? Quadrantals, very good. It must be at one of these 4 spots. It must be either here, or there, or there, or there. I'm hearing a lot of people saying the letter Y, which is great because sine goes with Y. So sine Y. Cosine goes with X and, is that the word letter for X? All right. And tangent is Y over X. Okay. All right, so when I said sine was -1, I really was kind of like I was saying Y is -1 because sine is equal to the Y. Just going to show you that little picture again quick because some people are like, why is sine equal to Y? That's so confusing. If this is X and this is Y and this is theta and they're on the unit circle, so therefore the radius would be 1, think it through. Sine would have to be opposite over hypotenuse, which would be Y over 1, so sine is Y. Cosine's X. And tangent must be opposite over adjacent, y over x. All right, so sine's y. It's technically y over r, but in the unit circle, r is 1, so it's y over 1, which is y. Okay, so if sine's the y, which of these spots, here, 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 or here, is it the one down low?
Yeah.
All right. Down here is the spot what comma what? 0 comma negative 1. That's the spot where y is 1. Here's negative 1. So therefore, what's my answer to the question? We wanted to know the angle, right? Well, what angle is it? 270 in degrees or 3 pi over 2 in radians. All right. Well, let's do another one that's like that. Sine of theta is undefined. What's theta? Nothing. There's nowhere where sine is undefined. Ooh, that's pretty good. Sine of theta is 0. You find that spot? Is there maybe more than one spot? Is it possible there's more than one? Possible there's more than one. All right. Figure out the answer to the question. Sine of theta is 0. Oh, and cosine of theta is 1. There's only one spot like that, and therefore there's only one theta that could work. I'm going to pause for a second. Draw yourself a picture. Because on the test, if you just, it'll be tempting. Like sometimes you go, oh, I can tell the answer is like pi over 2. You got to draw me a picture. Otherwise, you don't have work. If you don't have work, you don't get credit. Got to show me the picture. Show me where you must be. I'm going to pause while you try that one. Didn't I really say that y was 0 and that x was 1? So am I not at the point 1 comma 0? Right? Over 1 up 0. It's got to be that spot right there. If you're picking between saying 0 or 2 pi, which do you think is a better answer? 0. If you're picking between 0 and 2 pi, why is 0 any better? Only because we usually write our little requirement like this. Because mathematicians have decided that if you have a choice between calling it this or that, 2 pi is actually not as clean as 0 is, and they're the same place. 0 and 2 pi are in the same spot. And so 0 is simpler, and therefore 0 is a better answer. It's sort of like saying, I give you a question that the answer is 1/2, and you say 4/8. Not as good as 1/2, because 1/2 is simpler for use. All right. Next one. Sine of some mystery angle is 1 over root 2. And cosine of this mystery angle is less than 0. Figure out what the mystery angle is. This time, you can tell what the angle is. It's like pi over 6 or something like that. I'll pause where you give that one a shot. Remember, it always comes down to making me a triangle in the right spot where you label the sides and the angles. Make sure you're careful with the most common mistake in circle trig, negatives. All right, I'm going to pause for a second. So there would have been 2 answers, except for this statement caused one of them to get knocked out. You get cosine being less than 0 means cosine's negative, knocked one of your 2 answers out. Otherwise, where would the 2 answers have been? Sine is positive. It's hard to see that. Like you think, okay, you've told me this fraction, but think about this. I've told you that it's positive by saying that it's equal to 1 over root 2. That's positive, and therefore it has to be either here or here. Can't be here or here. Now this part is the part that knocked it down, so it won't have 2 answers anymore. As soon as I said cosine was negative, then it couldn't be here. All right, so now we're down to just here, and when you're here, you got the little sides on this thing, sides opposite, hypotenuse, and there's no negatives. What are you talking about, server? There's you said to watch out for the negatives. There is a negative. It's down here. It just didn't happen to matter because I never asked you, like, what's tangent of the angle. Get what I'm saying? If I had said what is tangent of theta, then you'd have had to go and look at the other angle. What would the answer have been if I had asked for tangent of the angle? What is tangent of this angle? TOA, opposite over adjacent, 1 over -1, so it would be -1. But this question was really asking not for tangent of the angle, it's just what's the angle? And this angle that's across from the 1 must be 30 degrees, true or false? False. Because, yes, there is something across from a 1 that's 30, but that's when you're in the 1, 2, root 3 triangle. We are in the 45, 45, 90 triangle, and therefore that's a 45. So I'm going to answer 45 on the test, and I'm going to get it wrong. Do you get why that would be wrong? Because this isn't where 45 is. What's there? It's a whole bunch of 45s to get there. How many specifically? 3 45s. 45s are actually pi over what's? Pi over 4s. And it's 3 of them to get there. So you'd have 3 pi over 4 is this spot, which is what we were trying to find. It's very easy for people to think that the answer was pi over 4 or 45 degrees. But if you're saying that, you're saying the answer is here because that's where 45 degrees is. This is where 3 45s is, or 3 pi over 4. Yes? How did you rule out that tangent spot down here? Okay, let me go back to the beginning. When I was doing this, I was crossing these off, I was saying all students take calc, just telling me where sign is positive. Down here, sign is not positive. Look at the original statement right here. Do you see that sign was given to you and sign was positive? So therefore, I know it's not just saying I'm positive, but you got to notice that, hey, there's no negative in this thing, therefore sign must be positive. Therefore, only 2 spots where sign is positive. The S spot and the A spot where all of them are positive. That's why I ruled that out. Okay? Good question. Thanks for asking it. All right, so one more quadrantal because I felt like that threw you just a little bit, but it shouldn't. You should be like, oh, cool, it's a quadrantal. These are easy. What is, not sine, how about secant of a quadrantal like 3 pi over 2? I'll pause for a second to find that one. Remember, don't do secant. Do the flippant sister. Pause for a minute while you try to find that. Well, first of all, you got to know that you're down there. Raise your hand if you knew that that's where 3 pi over 2 was. Okay, good. Then, if you didn't know that, you got to get those memorized. Now, this spot here is a place. Something, comma, something. Remember, you're on the unit circle. Therefore, this has gone 1 in every direction. It went down 1. It went to 0, comma, -1. And then that tells me I'm not going to do secant. I'm going to do the one that goes with secant, which is which one? Cosine. So I'm going to do cosine here and then get a flip of it. Which one is cosine? X. How do you flip 0? Well, first of all, you got to know what the bottom part of 0 is. 0 over 1. When you flip 0 over 1, you get 1 over 0, which is undefined. The answer was undefined. As in, there is no solution. Undefined. Okay. Let's try another one that's like that. Cotangent of pi. Remember, draw a picture. Sometimes it's a triangle. It's almost always a triangle, unless you're at a quadrantal. But you still draw a picture. Because where you are on that circle is telling you the answer. Okay. By now, you should have figured out you were at pi, which is over here. You figured out that that's a spot, -1, comma 0. You with me so far? Next, you have to have memorized that cotangent goes to tangent. So you can't really do cotangent, but you can do tangent. All right? And then tangent at this spot would be, is that x or y? It's neither one. What is it? What's tangent? Y over x. So therefore, it's 0 over negative 1. Is that okay to have 0 over negative 1? Yes. But that was tangent of this spot. Sorry, pi. And that was pi over x, which is 0 over negative 1. And that's just 0. But cotangent means you should flip that. And what do you get when you flip a 0? Undefined. Can't do it. But if you type this into your calculator and ask it to find cotangent, no, actually you can't do that. You can find tangent of pi, but then if you flip it, you have to learn that flipping 0 actually means that you've got 1 over 0, which doesn't exist. No solution. All right. So, is there any other topic, since the test is tomorrow, that you feel like you want to practice because we haven't talked about it very much? Yes? Okay, you can ask me a question from the homework. Good question. You got to figure out, without having to actually do all the bajillion rotations of this, where you are. So let's try to figure out, well, first of all, if I had just said tangent of pi, you'd have been here, all right? How about 2 pi? So this was a pi, this was 2 pi, because you go all the way around to there, okay? How about if we keep going? Where am I now? 3 pi. Where am I now? 4 pi. You catching on to a pattern here? So therefore, I got to either be over there or I got to be over here. And if it's 117 pi, can you tell, will it be on the left or will it be on the right? It must be on the left. That's where the odd ones are. So therefore, it's really the same thing as saying tangent of pi, because that's the same spot. It's coterminal, it's called. So really, it's like asking you tangent of pi. How do you do tangent there? Same, we just did it a second ago. That spot's what, comma, what? If you're on the unit circle, it goes over 1, negative 1, comma, 0. And therefore, tangent's y over x, 0 over negative 1. So it's 0. All right. Just to show you how many things you have to have memorized for this. Just think about this. Do you get, if I said this was in between quadrants 2 and 3, you have to know where the quadrants are. That's the first thing you have to have memorized. Quadrant 1, 2, 3, and 4. If I had said that tangent had to be negative, then you have to know ASTC to tell you that. Where is tangent negative? Well, tangent's positive here and here, so tangent must be negative in quadrants 2 and 4. You have to know which ones go with which ones. Like if I say secant, you got to go, oh yeah, that one goes with what? Cosine. So if you haven't got that chart memorized, it goes like this: sine, cosine, tangent goes with cosecant, secant, and cotangent, and those are flips of each other. Another thing you have to know is how to find the third side of a right triangle, because if I say sine of some angle is 4/5, you have to not freak out and go, we didn't memorize that one. You have to draw the picture of it and go, okay, well, you're telling me then that opposites 4, hypotenuse is 5. Could you figure out that side? Oh yeah, it's actually a 3, 4, 5. I know that one. Draw the picture and it helps a lot. What if it had been weirder numbers like 4.5? Is that possible? Yes, we could do that. And then you'd have to figure out what the third side is using the Pythagorean theorem. A squared plus b squared equals c squared. Okay. So, man, a lot of things to have memorized. That was a good question. Anything else? It's kind of quiet. I've got time to answer another question or two. All right, hold that thought just a second. I'm going to tell you what the assignment is because I get the feeling that some of you guys just, I just want to work my homework. I don't want to get ready for this test. You have a review for the test, which is kind of nice. There's one posted. And last night's homework was to just do some problems on, well, you didn't do this yet. So here's, everybody look in there under, actually, I think it's under yesterday's date. I'm going to pause for a second while we find that together. It's called Extra Practice. So here's what it looks like in our folder under Chapter 12. And today's date is 27th, which is right here. It says we have the test today still. Sorry, we don't, obviously. You have it tomorrow. This is the one we have to refer back to for tonight's homework. Review for Chapter 12, Circle Trig. Because we added that extra day to give you some extra practice. All right, so anyway, this extra practice and the extra practice key are what you're going to want to do for homework for tonight. Let's take a look at the one called extra practice. You do not have to do all of these. I'm going to recommend doing the evens, but obviously that has a whole bunch of built-in practice problems over there called the odds, which you could do. I also need to put more in the gradebook, so this is one where I'm very likely to say Dropbox it, and I will check it while you're taking your test. Because you're my first test tomorrow, so I'll have time while you're taking the test to put in your homework. Okay, so get your evens done tonight, and let's start that together. So find number 2. You're going to have to use my mouse to slide that. There we go. Tangent of 300. Remember, you have to be able to convert those to radians or just know where 300 is, because it's all about making this picture. 300 is like, well, 360, but minus some. How much is it? Minus 300 minus 60 then. So 360 minus 60. So this must be a 60. So then you basically got a right triangle. And once you got the right triangle with all its sides and angles, and be careful with the negatives, then you'll be able to get an answer like 1 over root 2 or whatever it is. Draw yourself a picture. All right. So again, there's a whole bunch of the same kinds of questions here. Then all of a sudden at the end, they start getting different. I would just don't make the terrible mistake of doing all these and then like skipping the last few. The last few are totally different kind of questions. These are quadrantal kind. And these kind, when they say evaluate, those are some of the toughest kind. We've practiced them, but they're all different kinds of questions, so make sure you do all the kinds. Okay, there was a hand up and it disappeared. Now there's a hand up here. Yes? Just the evens is all you have to do. If you want to do some odds, because let's say you do an even, and you go check the answer key, and you're like, totally wrong. Okay, look at the answer keys, see, figure out what you did wrong. I would go try the odd one then. You know what I mean? But it's up to you. I'm just trying to keep your assignment reasonably sized. If I say do all of these, that's a lot of homework for tonight. Yes? I'll let you formulate that question. Got it now? Okay. No. 300 degrees, let's figure out what it is together, but it's not that. But wait a minute. You said, did you say, I think I heard you wrong. Say what you said again. 300 degrees, I know that, so that's here, okay. Is that 5 pi over 3s? Okay, thank you. Now, I think that actually is 5 pi over 3s. I was thinking you were saying 5 pi over 6s. All right, that's 1 pi over 3. I got to count it up, because that's how I would do it. 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and just for good measure, that would be 6 pi over 3, which I know is 2 pi, and it's not that far. So yeah, this must be 5 pi over 3. Yep. Good. Could you give me a negative angle for 5 pi over 3? It is 5 pi over 3, but how could you say it if you were forced to? Hint, hint. How could you say it with a negative angle if you had to? Yes. It'd be negative pi over 3, or if you wanted to do it in degrees, negative 60 would work too. Now, don't give negative answers unless you're told to. Because normally they're going to say, your answers need to be between 0 and 360. That's telling you they're bigger than 0, right? And therefore, you're not supposed to give negative answers. Unless you're specifically told, hey, what's a negative angle? That would be in the same place, also known as coterminal. Yes? All right, the question is cotangent of negative 5 pi. Well, first of all, if you can draw me a picture of where we are, I know I can do cotangent because I'm just going to do tangent and then I'm going to flip it. So tell me where's this angle again? Would you say 5 pi over 3? But I just didn't hear it. Cotangent of what? Negative 5 pi. Just 5 pi. I thought you said over something. Okay. All right. So where is negative 5 pi? I think we did that one before. Do you remember that the odd ones were over on the left side? So here's 1 pi, positive 2 pi, 3 pi, and so the odd ones are over here. So we must be over here. So really, it's that spot. Can you draw a triangle for that spot? Nope. So then it's a spot that's like a place on the unit circle, which would be... Yep. And now that we know we're there, we're not going to do cotangent. We're going to do tangent. So what's the tangent of that? 0 over negative 1. So if the tangent was 0 over negative 1, this answer must be, flip it, negative 1 over 0. And then, yes, that is undefined. And therefore, the answer is undef. You said it was negative, and does that change where it is? Well, yeah, negative totally changes where it is. Negative was because we were over here. That's why it was negative. But putting a negative and dividing it by 0, it doesn't matter. If you divide by 0, no matter what you had, it just became undefined. All right. Any other last questions? Yes? Tomorrow's test is a no calculator test. You are correct. So anything that you would have had to leave as a weird decimal or whatever, you're just going to leave the exact answer. Like leave pi's in your answer. If it's a fraction like 4/17, you leave 4/17 in your answer. All right. That's all I got for you.